First of all, welcome all right? This year we're going to conduct this course in a slightly different manner. This is the way that it was conducted last semester too. We are extremely high-tech, okay? Everything is recorded as you see there, but it will not be available this semester. This is for the sake of next year's. There are a lot of things I need to say, so let me follow this line. But just keep in mind, the issue that this is being conducted in here doesn't mean that this is a stand-up show and I'm talking here and you guys just listening, all right? I need all of you, again, have a notebook. This could be the slides printed out so that you can write next to that, or you have your own notebook. Because next year's, I will refer to you guys saying that go back to your 202 notes, go back to your 202 notes, right? So every student should have a pen and something to write on in every amphi hour too. Just keep that in mind. Now let me go through. Okay, sorry, this is the first hour. I have a pen, I'm gonna write on the iPad, all right? So let's see how it's gonna work out. Now, I believe all of you know me because of the 102 class. I'm one of the instructors and I hate latecomers. Hello. I hope you don't do this again. There is a syllabus right there. You can pick one. The courses will be conducted by me and by Oyo Hoca. Sometimes it will be me here, sometimes it will be her here. So it's a fully integrated course. All sections will always have the same lecture hours, which is here, all right? So lecture hours are Mondays, this slot, and Thursday, 8:40, all right? And each of you have were registered to a section, right? I guess we have like 6 sections because we will have practice hours. It's in EB201. It's a special classroom just for practice hours. We will be with smaller groups with a lot of TAs, tutors, and us, and you will be solving problems that we gave to you before on that lecture. So we will be together. So it's a like very hands-on experience together, all right? We will have recitations prior to each quiz, and this is the textbook. Let me go on. So practice sessions. This is the difference of this IE202. Actually, normally, we didn't need to have these 4 hours or so. If these videos were available, we could tell you guys, okay, watch lecture 1 and then come to practice hours. That is our main motivation for following years, all right? Because everything will be done in these practice hours. What's gonna happen is, we don't have a practice hour this week, well, we're gonna have one next week. Before each practice hour, we will assign a homework, okay? Each homework will be graded on a scale of 3. The first 1 point is just for handed it before the practice hour, because the homework will be solved during the practice hour, all right? So the 1 point among 3, it's a 0-1 if you handed it before Monday 24, so Monday midnight, if you hand it in tonight, for tomorrow's and Wednesday's practice hours, you will get 1 point. I don't care how you performed, just hand it in. The other 2 points is for the content, but there is an option for you to update your homework after your practice hour. Because so at the end of the day, if you're not getting the whole percentage of the homework, you're not doing your job, right? Because our main motivation is for you to learn. So once we're done with the lecture hour, you should be able to know the correct answer of all the questions, and we're letting you to update your homework. The grading of the content will start after Thursday, so that everybody can update if you guys want to do, all right? One additional thing, this is again for your future, if you hand your homeworks in LaTeX, it's a special software, it's a lot better than Word, all right? It's a very good thing, and I'm switching to that in stage raporları too, so it's good for you to learn it. So there is a 1 point bonus, so it's a bonus, additional, you don't have to, but there's a 1 point bonus if you hand in your homeworks in LaTeX. It's a very good thing, it's good for you to learn it, so I suggest you do that. Piazza. How many of you have registered Piazza? Let me see the hands. A good portion. How many of you haven't yet? Yeah, it's a nice person too. I don't like that. You guys got an email from Oya Hoca, I guess, or Piazza team yesterday. You're supposed to first log in, all right? And everything will be conducted. Anything related to this course will be conducted there. Lecture notes are there. It's already there. For example, I downloaded this from Piazza, right? Questions will be there. Homeworks will be there. There's also a discussion environment. So you can post questions. We can post questions. And we want those discussions. Sometimes we post a question and the first 10 answers will get a mark, kind of thing, all right? So I suggest you log in there. It's no big deal. You're just supposed to write your name and that's it. Your emails are already registered because we have to invite you there. But you can, we really advise you to attach your pictures to your profile so that we will know who is him or her, all right? And then, because cooperation and participation in Piazza is really required, we really like it, all right? And we're gonna grade it. So it's good for you to be active there. The Piazza at the end of the semester will give us certain statistics, like how many questions did you post, how many comments did you do, how was your performance there. We got these kinds of statistics, and we can grade you guys based on that too. At the end, at one point, the grading will pop up. Stat sets and quizzes. There will be 4 quizzes, but at the end, we're gonna drop one out because there is no makeup for quizzes. So each quiz is 6%, and there will be a recitation hour prior to each quiz, and there will be a study set prior to each quiz. During the recitation hour, the TA will solve the study set questions. There is a project. It has 2 modules. In the first module, you're supposed to formulate a problem, then we're gonna solve it, okay? So, for solving it, we require all of you to learn Excel Solver because that's freely available everywhere. And we also have Express in the campus-wide laboratories, and you can actually download it to your own computers too. So Excel and Express, for sure, everybody should know that. We will dedicate 2 practice sessions for solvers. So you will be working with your computer, and a TA will come and help you if you have trouble in the syntax or in the way that the solver works. So at the end, everybody will learn how to use Excel and Express. There are optional solvers, because once you're in the senior year trying to solve your capstone design project, Excel, no use. Even Express is not that useful. So usually in the 4th year, all of you have to learn Cplex anyway. So we said, okay, maybe if you want to do it, since we're also allowing resources, we are a huge group of TAs and tutors, okay? Use us and try to learn Cplex. If I were you, I would do that, because there are 2 practice hours. You can ask the tutor help you, right? And it's, again, will receive bonus points. Cplex or any high up-to-date solvers will receive additional bonus points so that you'll learn it. There's also, I guess, oral exam regarding the solvers of Excel and Express only. Okay, what else? Exams, there is 1 midterm, 1 final. Both of them are in class, closed notes. Midterm is 30%, final is 34%. Makeup, we require our official healthcare reports that you're supposed to let us know as soon as possible, all right? And the makeup will be a comprehensive one after the final, so finals, midterm together will have a makeup. And if you remember me from 102, I keep saying the same thing. If you're not dying, come to my exams. I don't like preparing makeup exams, all right? So if you really are sick, okay, but if not, but just you feel not, try to come to the exams. FZ policy, we're only considering the midterm grade, quizzes, homeworks, we don't deal with that. You're supposed to get at least 25 out of 100 from the midterm. Other than that, 24.9 gets an FC, okay? So this is the overall grading. Be careful, there are like 6% participation. I'll discuss this in a minute. It breaks into pieces actually. 7% homework. 7 because we have 7 practice sessions, 5 plus 2. 5 for us, 2 for solvers. And each practice session comes with an homework. So that's homework 7%. All of you should have it because you have the option to update your homework anyway, all right? So that's what I'm saying. The project is 5%, quiz is 18, so it's 6% each. Midterm and final, 30 and 34, okay? What else? Oh, here it is. Now, you have it in the syllabus already, okay? Everything is scheduled. When it says lecture, it means here with us. When it says recitation, it means here with the TAs. When it says no lecture, it's no lecture, all right? For example, look at the week of March 2. We're supposed to have the first quiz on the Thursday slot there, all right? So we know that all of you are free. If we can find enough classrooms, we will schedule the quiz to this slot, to Thursday slot. If not, we're gonna let you know. The last column is for practice sessions. So this week, we don't have any practice sessions, but starting next week, for 3 consecutive weeks, we're gonna have practice sessions. Usually, if there is a practice session, we try to cancel the Thursday class so that you don't be in class for 6 hours, but we couldn't manage it all the time. Right? You will see that, for example, next week we have 4 hours of lecture and 2 hours of practice. It's a burden on us too. We are always on the stage, right? But we try to do it, but sometimes it's 4 hours of lecture plus 2 practices. But it's already scheduled. Everything is here, all right? And for example, midterm is gonna be on a Saturday because there was not enough place there. And so is quiz 4. Quiz 4 is again on a Saturday. Quiz 2 is where? On a Monday. Quiz 3 is again on a Thursday. Everything is here, and we're gonna stick to this schedule, okay? So you would know which Thursdays. For example, be careful. Every Monday we're here. For Thursdays, it's an 8:40 slot, so sometimes we're here, sometimes we're not, all right? And the practice of the week will again, oldu. The practice of the week will utilize the Monday material, all right? Okay. So let's go over the syllabus, now that you already have it in your notes, in your hands. So this is the tentative course outline. The prerequisite of this course is linear algebra and discrete math. We're planning to include 102 also because all the basics are also handled there. But it's not this year, but it will be. So this is a tentative course outline. Modeling phase is, we believe, one of the most important aspects for you, for your future. So for that, we're gonna spend a lot of time to teach you modeling, all right? So we have like at least 3 weeks on modeling. Then we're gonna start solving it with simplex. Then we go to duality, which is the main theory under optimization, actually. And finally, we're gonna finish with network simplex, which is network applications. You might remember most of these, well, at least the basics of this in my 102 discussions too. All right. Star's email. Like, I send an email, I'm assuming everybody get it. If you didn't get it, that means you're not registered to this class, so be careful about it. Piazza, I already told about it. You really have to be alert on this topic. No makeup for quizzes. That's why we're having one additional, all right? Well, be careful about, I mean, I don't even need to say this, but plagiarism, not cheating, but even plagiarism, we won't handle that, all right? Don't even try. All right. Again, I forgot to mention the last topic. No Kahoots this time, all right? So I don't need your phones, but there will be something in Piazza regarding this class. So be alert. All right, let's look at, you already seen this in 102, but it's okay to repeat some things, right? So that you really got it. So this is your curriculum. You guys are in here. For you guys, Math 132 is a must course. You have like 5 high restricted electives, and you have IE 342 in your second year. So this is your curriculum, all right? And this is the tree, president's tree, what you're supposed to take in order to be taking the other one, right? Why am I putting this? I'm putting this because I want you to see how important this course is, this 202. We are here, right? This one. So if you're not passing this thing, if you're not passing this one, you won't be able to finish your project electives. You won't be able to take your project electives in time, which would put an additional year. So this course is really crucial. Well, we do offer this course every semester, but it's a really important benchmark in our curriculum. All right, so this is the introductory course. At least this hour's material is a condensed version of what we discussed in 102, but I'll try to wrap it up in the remaining half hour of this hour. So let me start with the definition of industrial engineering. What is industrial engineering? All right, let's see what we have in here. So IE, industrial engineering, is a branch of engineering that deals with, let's read from here, design, improvement, implementation and evaluation of complex integrated systems, okay, composed of people, money, knowledge, information, equipment, and material. It's a lot of things to observe, right? But it's engineering related with complex systems. And we design, improve, implement, evaluate those systems. All right. How about OR then? There is this IE and OR. So what is operations research? Operations research, it's a tool. It's a decision-making tool. All right, so IE is an engineering branch. OR is a tool for you guys. It's an optimization-based tool, mathematical modeling and analysis. That's what I'll be doing for the rest of this month, actually, mathematical modeling. And then we're going to learn how to analyze it. So OR is a decision-making tool based on modeling and analysis to aid in determining how best to design and operate a system, usually under the conditions of scarce resources. Okay. This scienceofbetter.org, it's a nice web page. You can go and check in your free time to see some videos also. But just keep in mind, so IE is a branch of engineering. OR is the most important tool that we will be using in our career, all right? Both in the academic life or in the business life, corporate life. Okay, so where did this OR came from? You may remember these things. I told you, I explained these in 102.2. It dates back to World War II, okay? When Britain is actually in the Second World War, Britain was trying to plan the defense, air and sea defense of the country, all right? But be careful, it's a huge country. Of course, resources are scarce, very limited, right? And when you think about resources, we're talking about food, medicine, ammunition, manpower, everything. Every part is a resource, right? So everything is scarce. And we're in a war environment, and we need to defend the country, and in the meantime, survive, right? Okay, they said, how can we most effectively utilize these scarce resources? And then these are military resources too, so we have to be cautious, but we want to utilize them as efficient as possible. Then they actually formed an interdisciplinary team of scientists, economics, mathematicians, physicians, engineers, whatever. They come together and brainstorm, all right? At the end of the day, all of those brainstorming sessions led to a new method that we say linear programming, okay? So actually then, OR is operations research. Operations is actually coming from military. Research is coming from the new tool, new method, inventing the new method. Linear programming was actually conducted there. Okay? Once the war is over, is scarcity gone? No, of course. The resources are still scarce. Efficiency is required, productivity is required everywhere. Not just for defending, but surviving and being economically viable and everything. And then it was discovered that these techniques that they developed for defending the country can actually be applied in many other venues too, all right? And today, OR is applied everywhere, everywhere. Okay. Now, we learned what industrial engineering is. We learned what OR is. What is optimization then? Mathematical modeling, optimization. Those are different terms I might be using for the same thing. So what is optimization modeling? Mathematical programming. Let's read it from here first, and then we will read it again. So optimization is the study of special types of decision problems. Okay, we have a decision problem in which one seeks to minimize or maximize a real valued function. What do you think this is? We have a decision-making problem. We're trying to be good at one thing. What were we calling this last year? Come on, those guys on. Gun? Huh? Yeah? Performance measure, thank you very much. So we have a decision-making problem, and we are trying to minimize or maximize our performance measure. Time, money, distance, all right? Okay, what else? Of a set of decisions that the decision variable is going to decide by systematically choosing the values of those variables from within an allowed set. So, okay, we have our problem. I want to prepare the toast to my wife as soon as possible. It has to be the same quality. I shouldn't lose from quality. The performance measure that Tostkaizen had was with minimum possible time, right? And remember, there was one other thing that I keep saying that time. What was it? The environment, right? We have to play within the rules set for us by the environment, right? So this is our allowed set. I want to minimize or maximize my performance measure by deciding on my decision variables within my environment. This is optimization. Yeah? All right. That is one of the main tools in OR, okay? So operational research is a tool for industrial engineering, and actually optimization is the main tool in OR, right? Okay, let's focus on the main properties of OR. First of all, these are very cliche things that you would keep hearing about OR, but it has systems approach, interdisciplinary and scientific methodology, okay? That's like, okay, we step back, look at the problem from a different perspective. That is our systems approach. Interdisciplinary action. We always know what our customer is, how is the manufacturing going on. So it's usually an interdisciplinary team and scientific methodology. Okay? All right. Some applications of operations research. Remember, it started with World War II. So at the very beginning, we're trying to come up with the best defense mechanism of war, of England. So we utilized optimization. We devised linear programming to find out how to defend England. Okay, so where to put which army and how many ammo and how many food should be sent from where to where. Fine, that's how it started. How about today? What are we doing? Well, let's focus on topic by topic. Manufacturing environments. What can be the decisions that OR is actually helping? Manufacturing is our crucial process environments, right? Okay, facility layout. Which machine should go where? Machine scheduling. So which machine should process which job, when? Who does what when? Remember, I was saying that a lot. Workforce scheduling. Who does what when? Which manpower, which worker should do which job where? Cost minimization. Well, cost minimization is a performance measure that we could be using. Profit, again, a performance measure. Inventory. Okay, I have like 3 racks of material. How many should I store and where are inventory allocation decisions? So in manufacturing environments, examples are a lot. Finance. We did this, right? We spent a whole week on that last year. Portfolio optimization. Should you go with stock, bond, the options? OR is used there a lot. With risk minimization, they can have other measures too. In our case, we were trying to maximize our profit. Statistics. It's a basic mathematics course, no? But what are we doing in statistics? Is data fitting, error minimization. These are all OR applications in that area. What else? Networks. We spent a lot of weeks about networks last year. Some applications, some just for networks, remember? Transportation, shortest paths. Those Hamiltonian paths, Eulerian paths, if you remember. Those problems are actually, this year we're gonna learn how to model them. And maybe we're gonna learn how to solve some of them, right? Optimally. Last year I was talking about optimum solution and heuristic solutions. So that's why we know that OR is there too, yeah? Transportation, networks, computer networks, communication, real physical networks, pipelines, energy, or supply chains. Those are also be considered as networks. Okay, what else? These are just some advertisement slides about OR, actually. OR also delivers significant value. It's not just decision-making, all right? First of all, it teaches how to make the decision. Who does what when, where. It's good to know a way for doing that, right? Otherwise, will you flip a coin? Of course not. So first of all, it teaches you how to make the decision. Good. And while doing that, it also improves a lot of things. Remember the continuous improvement? Again, we go back to Toast Kaizen, yeah? So organizations worldwide, in business, military, healthcare, public, everybody is actually recognizing the beauty of OR, right? For providing quantitative and business insight into complex problems. By just stepping back one step, looking at the problem from a systematic point of view, and then teaching how to make decisions will actually gives a lot of value to complex problems. What else? Performance. It does improve performance because that's our main motivation, remember? So improving business performance by embedding model-driven intelligence into an organization's information systems to improve decision-making. Fancy words, but yeah, it does that. What else? Cost reduction. If cost is your performance measure, well, your decision maker will end up with something with less cost. Of course, that's how it is built up, right? Forecasting. This is a very typical decision-making problem, yet it is really hard. Forecasting is actually how many cans of Coke will Migros sell next semester? Tomorrow. Right? How many? How many loaves of bread should there be so that they're not stuck out? And a loaf of bread, it gets ruined at the end of the day. Right? This is forecasting. Forecasting the future. How many should I have in my shelves so that I sell it, I'm not stuck out, and I got my profit? It's a very hard problem, but it's a very daily life decision. Yeah? And OR is used there too, of course. Improve scheduling, who does what when? Efficiently scheduling staff, equipment, events, and more. Scheduling has many aspects. Well, we are scheduling aircrafts. Which aircraft should do which segment? Think about it. They are very, very expensive resources. So you don't want it to lay down. It says ground time. So for an airline company, minimizing the ground time of your aircrafts is a very important performance measure. So scheduling each aircraft. Well, of course, you don't want to send it for empty destinations, because, I mean, having it on the ground, okay, you're not utilizing it, but having him fly is also, you're paying for the jet fuel, right? So this is really a crucial, important decision. And it is called scheduling. It is a part of scheduling, and it's really important. Scheduling staff, equipment, events, and more. Everything we do there is OR. Pricing, like, again, from maybe airline industry, like the whole flight, and you buy the ticket today versus you buy the ticket last month, each seat has a different price. Who determines that? Based on what? Why is this $10 cheaper than the other one? This is called pricing, all right? And what they're using there is mathematical modeling and optimization. So it's again OR, working in the airline industry. Productivity, helping organizations find ways to make process and people more productive. Okay, if getting out as much tasks as possible in 2 hours was your performance measure, you're gonna place your environment based on that, yeah? Sorry for this. This is the first hour. We're learning. We're gonna get the hatch of it. Increasing revenue is, of course, one other issue. Oh, we go on. Quality. Improving the quality, as well as quantifying it. How would you measure quality of a product? Good, bad? No, we're engineers. We gotta have numbers, right? Then we need to speak with mathematics there. We need to quantify being good or being bad, right? This is quality control. And what we're doing there is, again, OR. Resource utilization, it's how it started already. Risk is something interesting. It's more of a newer topic, let's say, minimizing risk, defining risk. While for portfolios and finance, it was always there, but for other environments, again, risk can be an issue. So measuring it, quantifying it, and if possible, make your decisions in a risk-averse manner can also be other ways to utilize OR, right? increasing speeds, throughput, decreasing delays are just coming from being efficient anyway. Okay, more towards the meat now. OR modeling. What are we talking about when we say OR modeling? In spite of the fundamental differences, now this is us. We have our own glasses, and we look at different problems from different sectors as the same. We can see that they are the same. How can we do this? I was saying with our glasses. Well, our glasses are actually our mathematical models, all right? In the abstract level, we look at the problems, then we define our environment and our decisions and our performance measure. And then when we look at those problems, they may be the same. One coming from a healthcare industry, one from a restaurant, or one from Mercedes company. At the end of the day, when you look at it from a mathematical modeling point of view, they may be the same. That's why we're going to learn mathematical models first, right? So when we say model, though, these are just examples like a physical network versus a computer network. The Turkish road highways versus the computer networks. From one point of view, they have nothing in common, right? One are physical roads that you drive on, and the others are your cell phones communicating with each other. But then, if you define your nodes and arcs, then you have networks. All of them, both of them converge to a network of nodes and arcs with connections. Then we put the values on, whatever our performance measure is, right? So these are just... Then, it's our responsibility, or our model's responsibility, to observe and understand the inner workings of a system in conjunction with experts, all right? So that we actually come up with the correct model. Now, what is a model? Well, there are many different models, actually. There are versions of it. But a model is a structure which has been built purposely to exhibit features and characteristics of some other object. Model. So, road models, monorail planes, simulation models, mathematical models, all right? We're going to come up with different versions. Let's read this first together. So the essential feature of a mathematical model in OR is that it involves a set of mathematical relationships. So this is it actually. We go, understand the real life, learn the inner dynamics of it, and then we come up with mathematical representations of that inner dynamics, okay? So equations, inequations, logical dependencies, whatever it is, we actually try to convert the real life problem to mathematics. Okay? That's why we're calling it as mathematical model, OR model. Characterizations of the relationships in the real world. Now, why do we do this? Why do we need OR modeling? Well, first of all, it really helps us a lot in understanding the problem, because you're trying to write those mathematical representations. So in order to do that, you really learn it by heart, okay? Once we convert it to math, we can immediately see certain things there, all right? By just looking at it as preparing toast, we may not see everything, but when we convert it to x and y's, it's going to say x plus y less than or equal to something, then it gives you an idea of what actually is going on. And you can easily use universally available knowledge because it's algebra and math we're talking about. You may remember this slide too. So we have our problem on this corner out there. I don't know if this is going to work or not, but we have our problem here. No, it's not working. All right, anyway, we have our problem, okay. Now we define our environment, we decide on our performance measure, and then we come to our model. You're not seeing it. Yeah, you're not seeing it. We come to our model, okay. Now with the model, we apply our mathematical skills, what we learned, and then we come up with a conclusion. This is actually the conclusion of the mathematical model. It's going to say x1 equals 5, x2 equals 7. Once you get that, you have to translate it back to the decision, because the original problem has nothing to do with x1 and x2, but the mathematical model has it. So you model it, you solve it with the tools, you got the result, now you have to convert it back to the original decision and say, okay, Ahmed is working in machine 2 for 5 hours, and Aisha is working in machine 3 for 6 hours. Look at it, if it's doable or not. If not, you made a mistake in your model anyway, so you update and you go on. All right, this is the modeling process. Validation is checking if everything was correct or not. Some success stories, just some numbers from real life of why OR is actually helpful. Let's look at these. I mean, crew scheduling, American Airlines. This pricing issue, why this seat is $10 more than the other one, is actually a breakthrough, word-breaking kind of way of doing it, because they really changed how airlines work, okay? This pricing issue is really important there. Crew scheduling saves American Airlines $20 million per year. It's a lot of money, no? Shipment saves Yellow Friday, whatever it is. This trucking, GTE, local capacity expansion saves $30 million per year. These are real numbers coming from real companies, actually. $1 to someone else. These are just some more numbers, okay? Who saved how much by utilizing what in there. So it's the applications are from many different industries, and the problems solved are again from many different variations, but in a nutshell, everybody is utilizing optimization, right? I think I'm gonna stop here. Let's have a 10-minute break. And in the meantime, I'll have to handle. In the next hour, I will start writing on this thing, hopefully. So you may need writing too. See you in 10 minutes.